The goal of this video is to try to figure out the antiderivative of the natural log of x. And it's not completely obvious how to approach this at first. Even if I were to tell you to use integration by parts, you'll say, wait, integration by parts, you're looking for the antiderivative of something that can be expressed as a product of two functions. It looks like I only have one function right over here, the natural log of x. But it might become a little bit more obvious if I were to rewrite this as the integral of the natural log of x times 1 dx. Now you do have the product of two functions. One is a function of x. It's not actually dependent on x. It's always going to be 1, but you could have f of x is equal to 1. And now it might become a little bit more obvious to use integration by parts. Integration by parts tells us that if we have an integral that can be viewed as the product of one function and the derivative of another function, and this is really just the reverse product rule, and we've shown that multiple times already. This is going to be equal to the product of both functions, f of x times g of x minus the antiderivative of, instead of having f and g prime, you're going to have f prime and g. So f prime of x times g of x dx. And we've seen this multiple times. So when you figure out what should be f and what should be g, for f, you want to figure out something that it's easy to take the derivative of, and it simplifies things, possibly, if you're taking the derivative of it. And for g prime of x, you want to find something where it's easy to take the antiderivative of it. So a good candidate for f of x is natural log of x. If you were to take the derivative of it, it's 1 over x. Let me write this down. So let's say that f of x is equal to the natural log of x, then f prime of x is equal to 1 over x. And let's set g prime of x is equal to 1. So g prime of x is equal to 1. That means that g of x could be equal to x. And so let's go back right over here. So this is going to be equal to f of x times g of x. Well, f of x times g of x is x natural log of x. So g of x is x, and f of x is the natural log of x. I just like writing the x in front of the natural log of x to avoid ambiguity. So this is x natural log of x minus the antiderivative of f prime of x, which is 1 over x, times g of x, which is x, dx. Well, what's this going to be equal to? Well, what we have inside the integrand, this is just 1 over x times x, which is just equal to 1. So this simplifies quite nicely. This is going to end up equaling, let me put it right there. This is going to end up equaling, all right, x, natural log of x, minus the antiderivative of just dx, or the antiderivative of 1 dx, or the integral of 1 dx, I should say, or the antiderivative of 1 is just minus x. And this is just an antiderivative of this. If we want to write the entire class of antiderivatives, we just have to add a plus c here. And we are done. We figured out the antiderivative of the natural log of x. And I encourage you to take the derivative of this. For this part, you're going to use the product rule and verify that you do indeed get natural log of x when you take the derivative of this.